Talk Live. You can bring up anything that you want here, toll-free, 855-450-FREE, the SACL CAI toll-free line, 1-855-450-3733. Join us on our website over at freetalklive.com, where we've got a lot of features, and we give them away to you. In fact, the mobile site is one of those features. You can go to m.freetalklive.com. You get quick access to our live streams. We've got broadband, midband, and narrowband versions of our streams. So if you're in an area in which you don't have the greatest internet connection, but it's still there, maybe you need to use our midband or our narrowband streams. Maybe they would fit your bandwidth better. That's why we have choices for you, and they're all free. Go to m.freetalklive.com. Let's continue. We've got Sam in Texas. Sam, you're on Free Talk Live. Is this Sam I Am?
It is. Hey, how you doing,
Sam.
Ian?
Good, man. You're on with Julia and Johnson.
Hey.
Hey, guys.
Oh.
Johnson, I'm glad you're on. You're always a skeptic of some of the stuff that I'm going to talk about tonight.
Sure.
Now, we're taught in school that the sun is at the center and all of the planets are out on this perfectly flat plane, and they orbit around the sun just like that. But Nassam Harriman, who is really the modern-day Einstein that's coming up with a unified field theory and a number of other really interesting ideas, he equates that to teaching kids that the Earth is flat. Because what happens is the solar system within the galaxy is spinning around, and so the sun is actually acting more like a comet traveling through space. And there is a Nobel Prize winner named Dr. Bott who has come up with this theory that kind of explains a different model of how the solar system is likely operating. And what he comes up with is really that the sun is acting more like a comet with a coma tail, and the planets are inside of that coma. And if you were watching it from the side, what you would see is the sun go whizzing by, and then shortly behind that you would see, Venus making a small, tight corkscrew, and then you'd see, Earth making a slightly larger one, and by the time you get out to Saturn, you'd have quite a large corkscrew, but that they're kind of forming this cone behind the sun. Does that make sense?
I'm doing my best. It's hard without graphics to go along to really explain where you're coming from. But I mean, I am understanding what you're saying about from a larger perspective, the solar system itself is moving through space. Is what you're saying?
I mean, it sounds like that's a theory that's kind of refuting the expansion of space itself, though.
Not exactly.
Having it have a tail.
What it's simply saying is that if you look at where our solar system is in the Milky Way galaxy, it's on one of the outside spiral arms, and those spiral arms are rotating. So if you were sitting outside the galaxy watching our solar system go by, you would see the corkscrewing and the cone of the planets behind the sun. And what it suggests is that the sun maybe is creating sort of a cavitation bubble or a vacuum which our solar system exists within. And the evidence that kind of supports this is the Voyager satellite. That was launched in I believe in the 70s, and it still hasn't left the solar system, and in fact it's slowing down. It's like there's some barrier that it's reaching at the edge of the area of space that as it's getting outside of the solar system. And they're quite worried if the sun is this comet traveling through space, maybe space has areas of denser medium that the sun goes through, and what that would do is tend to increase the pressure on the sun, condense the coma, and cause changes within the solar system. And we've seen, there was a story about new massive storms on Saturn, and several of the other planets have been changing pretty dramatically over the last decade, and this may be part of the root cause of that. And so what it kind of suggests is that scientists are somewhat worried about solar cycle 24 because it's had an unusually long quiet period, and it's also been unusually quiet. And what they're worried about is that when it does kick back off, it could be quite the show and cause some interference with life down here on the planet.
So where are you going with all this? Are you just trying to scare people, or what? I want to hear where you're gonna go. Where you're?
I'm getting a credit card.
What? You're getting a credit card?
Because if the world's going to end, it's time to spend.
All right, hang on, Sam. We'll bring you back here. 855-450-FREE, because he said he wanted to lay a groundwork. So what's next?
Although we can't feel it, our solar system is constantly being changed by galactic wind. The wind is composed of gases like hydrogen, helium, oxygen, and neon, which form a very wispy atmosphere between stars. This gas is called the interstellar medium. Like a bicycle traveling in a crosswind, the wind that the solar system feels is actually a combination of the solar system's movement relative to the galaxy and the movement of the interstellar medium itself. The solar wind pushes out against this galactic wind, forming a bubble called the heliosphere. The outer boundary is called the heliopause and is blown into a teardrop shape by the galactic wind.
The equations we wrote with Einstein field equations with a torque term in it, the manifold of our galaxy is no longer, in terms of geometry of space-time, is no longer a sphere, but it's actually a double torus structure with vortices which are visible. We know there's a huge vortex coming out the center of our galaxy. At the North Pole, we've been able to measure it, the North Pole of the galaxy, if we want to call it that way. And it's a large vortex, 3,000 light years long. And we know that the galaxy looks like a disk. And so those are the dynamics of the double torus, you know, with a torus on top and a torus on the bottom, like a sphere with two vortices and an equatorial disk. Our solar system is in an arm coming out of the huge black hole in the center of our galaxy. And that arm is rotating away from the center. And our solar system is stuck in that galactic arm, is rotating in that galactic arm, and it passes back and forth across the galactic equator where the space-time manifold flattens and where you would get the maximum amount of radiation, galactic cosmic rays, which are particles that are accelerated throughout the galaxy and that are hitting matter as they go along and creating gamma rays and all sorts of dynamics. Now, when we pass that equator, I realized that that may be where the ancient Mayans and the solar calendar and all this was describing that there was going to be an energy increase, an energy event in our solar system resulting from our relationship to the galactic center, which they talked about a lot. And that when we cross the galactic equator, we would get bombarded with more galactic cosmic rays that would activate the plasma dynamic of our sun, and that the sun may go through a larger cycle in which in that moment it gets hotter and more active than it was in between when we're not going through the galactic equator. The Mayans said that that was going to occur around 2012, and I started to study the solar cycle, and I realized that the sun flipped its poles every 11 years, and that every 11 years it would get hotter, more active, and then cooler and less active in between the 11-year cycle. I realized as well that the last cycle would occur approximately in 2000-2001. Adding 11 years to that matched the solar calendar of the Mayan, in which you know, the sun would flip this pole and get active again in 2012. However, I deduced from the research, from my understanding of the mechanics of the physics and astrophysics of our sun, from my equations describing the plasma dynamics on the surface of the sun, my balance equation that describe a relationship between the gravitational side of our sun dynamics and the electromagnetic side of our sun, that all these components put together would make this specific 11-year cycle between 2001 and 2012 most likely a much more active and a much more dynamic cycle than anything we've seen before since we've been recording since approximately Galileo.